Okay, take your attendance. Okay, class. So let's restart our lesson. Okay, we'll be continuing with what we did yesterday. We just continued with capacitor. Okay. Okay, so let's go to the documents. Okay, so we just introduced with what is capacitors and capacitance. So what is capacitor? It's a device that store charge or energy. Okay, so store charge or energy, but more to say store energy. Okay, stores energy. So the capacitance defines what? The amount of charge stored in each plate to the voltage between the plates. Okay, it's a capacitance. So unit is farad, then it found to be 1 farad means you can store 1 coulomb of charge for 1 volt between the plate. Okay, and we talk about the process of charging and discharging that day. When charging, the capacitor will start to charge until the voltage of the capacitor rises to the voltage of the battery. The current becomes 0, then stop charges. Okay, no charge will crosses the plate. Okay, no charge will crosses the plate. It's an insulator. Okay, yeah. So greater the resistance you use to charging, normally we use a resistor. If no resistor, then the current going to be infinite, so can damage the capacitor. So we need to have a resistor. So if the resistor is huge, the charging process takes slow. It takes longer time. If resistance is low, the charging can happen fast. Okay. Okay. Okay, so the day we did this question. So today we're going to talk about series parallel, capacitor in series and parallel. Okay. So for that, let me go back to the slide. Okay. Okay. Before we go to that, just one example. There is a few example. I just used this one example. Okay. Before we go to series parallel, you see this circuit. Okay. This is a circuit. A 30-volt battery was connected to a 5 kilo ohm, and there is a capacitor of 470 millifarad. Okay. So a large capacitor is used to shown above. A camera flash. This is like a camera flash circuit. So the charge it stores when the control system connects to the capacitor directly to 30 volt. Okay. So what is the charge it stores? How much the charge is stored by the capacitor when connected to the 30 volt? So what's the formula must be used? C equals to QOV, right? So C is 470 millifarad changed to farad, multiplied by the voltage, which is 30. Okay, so you get the charge. Okay. So yeah, so the first calculation should be, you can go for C equals to Q over V. So Q should be CV. So C is 470 times 10 power of -3 farad multiplied by the voltage applied, 30 volts. So you get the total charge in coulomb stored in the capacitor. Okay, next. What is the average discharge current, if any, when the control system connects a capacitor to the discharge tube? It discharges in 0.2 milliseconds. So what the B is asking for? What is the average discharge current? Okay. Yeah, they said average because actually the current through when capacitor discharges, the current will drop exponentially now. But in this case, they're asking average current. So when they go for average current, so they say the total charge discharges took 0.2 milliseconds. So what formula comes to mind to get the average current? Current is the rate of flow of charge, right? You learn in AS, so Q over T. So you know what is the total charge stored in the capacitor, which you know from part A. Okay, you know this answer. The charge is tossed. The charge has been released in 0.2 milliseconds, 0.2 times 10 power -3. So you get the current. Okay, get the current. So in this case, okay, this should be the answer. The QCV, so 14 kilo ohm. The current is Q over T, so you get about 70 kiloampere of current is flowing through the capacitor. The current is quite huge, so that the brightness become quite high in a short period of time. Okay, it's a flash. You get the flash. Okay. Okay, now, so we go to the capacitor in parallel and series. Okay, guys. So this is going to be exactly same as your resistance. You know, resistance can be connected in series and parallel. If capacitor connected in series, okay. If I go back to the whiteboard. Okay, if I go back to the whiteboard, sorry. You know, last time, remember, for resistor in series and parallel, okay, what's the equation? You know, if resistor is connected in series, okay, you get the formula for how the current change, how the voltage change, how the resistance change, right? I mean the total current, total voltage, total resistance linked to this resistance, right? 1, 2, and 3. Okay. Let's say for series, I total is what? If the resistor connected in series, the I total is same as I1 equals to I2 equals to I3, right? Current same. Okay. Voltage is what? V1 plus V2 plus V3, right? Each voltage in series add up will be the total voltage, right? For the circuit. Okay. Then how the total resistance? R1 plus R2 plus R3, correct? Parallel will be I total is I1 equals to I2 equals to I3. Current is same in parallel. V total is V1 equals to V2 equals to V3. Okay. Voltage is same in parallel. And resistance is what? 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay. So this is what you learn in your for resistance, right? Okay, same things. These equations are derived based on V equals to IR. From V equals to IR. Okay. So if I make I as the subject, it's going to be like okay, I make it V equals to IR. So this equation is V equals to IR. Okay. Okay, now we come to capacitor now. When can come to capacitor, okay, series parallel. Okay, series parallel. Okay, when the capacitor is connected in parallel in series, okay, in series, the equation we're going to link for capacitor is V equals to what? Actually, capacitance last. Capacitance is what? Q over V, right? Q over V. So I make V as the subject because I want to make similar as your resistance. V equals to IR. So here I make V as the subject. It's going to be V equals to Q over C. This is V equals to IR. V equals to Q over C. Okay. So you see here got current, here got charge. Okay, the current and charge works the same way. Okay, the resistance and the capacitance is opposite. You see here resistance, the voltage and resistance is parallel or proportional, but here the voltage and capacitance like the other way around. Okay, so shortcut how this equation is going to change in series and parallel for capacitor is the current is replaced by charge. It's just charge. Okay, you can imagine like this. Okay, the current is like the charge. So the formula for the charge, because current is rate of flow of charge, right? So in series, the Q1 equals to Q2 equals to Q3. Okay, the charge stored in capacitor in series is the same. Okay, for example, let's say you have a circuit. Let's say the first capacitor store 5 coulomb of charge. So all capacitor will store 5 coulomb of charge. Okay, all will have 5 coulomb of charge. Okay, but the total charge stored in this circuit, still 5 coulomb. Okay, not 15 coulomb, still 5 coulomb. Okay, why still 5 coulomb? You see, if this is a positive plate, the charge on the left plate is positively charged, positive 5 coulomb. Okay, positive 5 coulomb. Okay, let me show you. Okay, so on the left plate we'll have a charge of positive 5 coulomb. On the right plate here will be negative 5 coulomb, and same, this will be positive 5 coulomb for the second capacitor. This is negative 5 coulomb. The left part positive 5 coulomb. This will be negative 5 coulomb. The charge accumulated. Okay, after it charges, okay. If this capacitor is connected to another battery, another circuit where got light bulb, let's say, okay, so the total charge going to be released to the light bulb is only 5 coulomb. You know why? Because when the battery is connected, the negative 5 coulomb of charge accumulated on the first capacitor on the right, let's say it's first capacitor, second, third capacitor. The first capacitor will release the negative 5 coulomb of charge. Negative 5 coulomb of charge will flow into the light bulb. Okay, and this negative 5 coulomb of charge will come over here, will neutralize this plate. Okay, so negative 5 coulomb reach to the positive 5 coulomb. This become neutralized. The negative 5 coulomb in between here, the second plate will go to this positive 5 coulomb, neutralize. This negative 5 coulomb will go to this plate, will be neutralized. So finally, how much of charge will pass the battery at the light bulb is only 5 coulomb. Only 5 coulomb. So conclusion is, okay, the conclusion is the total charge of the circuit is 5 coulomb. Okay, so Q total is Q1 equals to Q2 equals to Q3. Similar as your resistor current formula, equal. Okay, but in parallel, the charges will be Q1 plus Q2 plus Q3. Okay, like parallel. Sorry, what I'm doing here. Yeah, correct. Parallel, I made a mistake here. Parallel, the current is added, right? The total current. Okay, added. So for the charge also will be added. So that means you have 3 capacitor you connected in parallel. Okay, if you connected in parallel, the total charge of the circuit is, if this is 5 coulomb, this is 5 coulomb, this is 5 coulomb, the total charge can release in this main branch. Okay, let's say it's a light bulb. So will be 15 coulomb. Okay, the total charge can be released. So Q total is Q1 plus Q2 plus Q3. Okay. V voltage works the same way as resistance. If it's in series, the voltage is split. V1 in series, V1 plus V2 plus V3 is the V total. Okay. In parallel, the V total is V1 equals to V2 equals to V3. Okay. Yeah. So now this is the difference. The current is taken over by charge. The voltage is the same. Finally, capacitance. This is the something new. capacitance, you see the formula here, the V and C like inversely proportional. Here you see the V equals to IR, V equals to IR, the resistance and the V like proportional. So here what happened? The equation will be the other way around. For series, the total capacitance will be 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over C3. In parallel, the C total will be C1 plus C2 plus C3. So this is the 6 formulas need to follow for capacitor in series and parallel. Okay, capacitor in series and parallel. Okay. Okay, now let's see. This is a shortcut. You have to remember these 6 equations. Okay. So, but now let's see how they got these equations. Okay, so let's go to the slide. Okay, you can see this slide. Okay, the first thing we go is resist capacitor in parallel. Okay. So if these 3 capacitors connected in parallel, okay, for 3 capacitors connected in parallel, the voltage is the same. Okay, so VAB is equals to the all 3 voltages of each capacitor. Okay, so this is for the voltage equation. Then by conservation of charge is conserved. Okay, the Q total, Q is the total charge of the capacitor, is Q1 plus Q2 plus Q3 in parallel. Okay. Okay, now, so the Q1 plus Q2, the Q1 is the charge stored in the first capacitor on top. So we know Q1 is C1 V1 actually, C1 V1, but V1 is the voltage across the first capacitor, but V1, V2, V3 is same as the V0, right? V0, so therefore we straight away put C1 V0. C1, Q1 is C1 V1, but V1 is the V0. Voltage is the same, right? So Q2 is C2 V0, Q3 is C3 V0. The total Q is C total V0. Okay, C total V0. So we cancel the V0, eventually get the total capacitance formula in parallel. The total capacitance formula in parallel is all the capacitance are added. Okay. So any questions so far? Okay, hope you got the idea. Okay, let's move on. So this is the 3 formulas you have to remember, for the voltage, for the charge, for the capacitance. Okay. So for example, let's say I give you one question. Okay. Let's say I give you one question in series. Go to series first now. Oops. Okay, let's say I say you have one battery. Okay, you have a battery. You have 3 capacitors. Okay, you have 3 capacitors. This is 5 microfarad. This is 10 microfarad. This is 20 microfarad. Okay, you have 3 capacitors. 1, 2, 3. Okay, so this is a circuit sorry, this should be the first one we learned parallel, right? Sorry. So we go for parallel. You have 2 batteries. The 3 capacitors are connected in parallel. Okay. Okay, 5 microfarad, 10 microfarad, and 20 microfarad. Okay. Okay, now can you work out for me? I give you 2 minutes. Can you work out for me? What is this is 1. The first one is 1, the second one is 2, third one is 3, the capacitor 3. Okay, can you work out for me? What is the Q1, Q2, Q3 What is V1, V2, V3? What are the charge stored in each capacitor, and what is the voltage across each capacitor? Okay, I give you 2 minutes. Come on, work out by using the formula you learned just now. Okay, the formula is this formula. Okay. Okay, so these are the formula for parallel, right? Okay, come on, give me 2 minutes. I give you 2 minutes. Work out. Okay, do you got the answer? Okay, how do you find the answer? Okay, at any sequence you like. Okay, first thing. Okay, what you can find first? What you can find first? Okay, first you can find is, okay, I made a mistake. You need to have the voltage. Let's say I give you 10 volt here. Okay, I give you a 10 volt on top. Okay, first, whatever circuit they give in capacitor in parallel, the first thing you need to find is the total charge. Okay, sorry, total capacitance. First thing you need to find is the total capacitance, always. Okay, so in this case, the circuit, what is the total capacitance of the circuit? So 5 plus 10 plus 20. The total capacitance is 35 microfarad. Okay, so capacitance in parallel is added. Okay, next you need to find is the total charge. What is the total charge of this circuit? Total charge. Okay, total charge you can find by using the capacitance formula. C is equals to what? Q over V, right? So Q is CV, C total, V total. Total charge is C total times V total. So C total is found to be 35 microfarad, so 35 times -6. V total is what? Total voltage is 10 volt. Okay, so you can get the total charge stored in this circuit. Okay, so in this case, the total charge stored is 35, so it's like 350 microcoulomb, right? Okay, now can you work out these values? Can you work out these values? V1, V2, V3. The first thing we can get, of course, the V1, V2, V3, right? V1 is same as V2, same as V3, same as the total voltage. So V1, V2, V3 is definitely all are 10 volt. Okay, all of them are 10 volt. Okay, yeah. So what is the charge at the one? Q1? Q1? What is the charge stored at Q1? So charge stored at Q1 is C1 V1. C1 V1. So yeah, right. C1 you can always go for C equals to Q over V. Okay. So Q1 is C1 V1. So C1 is 5 microfarad. Okay. And V1 is same as the main voltage 10. So it's 50 microcoulomb. The charge stored in one is 50 microcoulomb. And same thing you can do for the 2 and 3. The 3 is C2V2. So C2 is 10 microfarad and 10 volt. So you got 100 microcoulomb. And Q3 is C3V3. So 20 times 10, you get 200 microcoulomb. Okay. So the charge stored in Q1, Q2, Q3 is like this. And the total charge is how much? We got 50 plus 100 plus 200. You got 350 as we calculated earlier. Yeah. So this is parallel. Okay, parallel circuit. So capacitor in parallel, the total capacitance is add up. Okay. Any questions so far? no questions. Okay. So now let's we go to the series. Okay. So this the derivation you have to know. The derivation, how they got this capacitance formula, you have to know. You have to know the derivation. Voltage same, charge is added. The charge is C1 V0, C2 V0. Then V0 cancels. You get the total capacitance formula. Okay. Now we go to series. In series, the three capacitors connected in series. So the V0, the total voltage is VAB, VCD, and VEF. Okay, all three voltage add up, right? Okay, first equation for voltage. But V is what? V is Q over C1, right? Q, what do you call? C goes to Q over V. So V is what? V is Q over C, right? Q over C. So all the voltage here we change. VAB is Q over C1 as capacitor 1. Q over C2, Q over C3. Because why they on top they put Q, 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 same Q, because charge is same in series. Okay. The V0 we can put Q total over C total, C total. Okay. So all the Q cancel. So eventually get the capacitance formula in series. It's 1 over C equals to 1 over C1 plus 1 over C2 plus 1 over C3. So the derivation we have to know. Okay. So conclusion is, as I said, the conclusion is this is the formula you have to remember. This is the formula you have to remember. Charge exactly same as your current in the resistor. Okay. So instead of current now it's going to be charge for capacitor. Okay. Voltage formula remain. Okay, remain. But only the resistance now replaced with capacitance, but the other way around. Last time we know that resistance in series, resistance increases. Parallel, resistance decreases. But now for capacitance, you want to get big capacitance means you must connect them parallel. Okay. Last time resistance, you want to get big resistance means you connect series. Okay. Now in capacitance, you want to get big capacitance, connect parallel. You want small capacitance, connect in series. Okay. So this is the idea. Okay. So let's we go one example again. Okay, one question, one example. Okay. You see this question? Look at the solution. Does it make sense for you? A steady PD of 200 volt is maintained across a combination of two capacitors. A of capacitance 2 microfarad, B of capacitance 0.5 microfarad. So two capacitors. Okay, you got a 200 volt of voltage. One is 2 microfarad, another one is 0.5 microfarad. Connected in series. Okay, they are connected in series. What is the combined capacitance? So because in series, 1 over C is 1 over C1 plus 1 over C2. So you know, you substitute the values, 2 and 5 reciprocal, so you get the totals found to be 0.4 microfarad. So you can imagine, okay, this is actually same as one capacitor, single capacitor, which has a capacitance of 0.4 microfarad. Okay. You see, capability to store the charge reduces when you connect them in series. 2 microfarad, 0.5 microfarad finally becomes 0.4 microfarad. Okay, store less charge. Okay. B, the charge stored in each capacitor. How much the charge stored in the 2 microfarad and 0.5 microfarad? Okay. So how do you find the charge? Okay, so to find the charge, Q equals to CV. So C, you know, for the one CV, C is 0.4 times 10 power of negative 6 and multiply by 200 in series, right? Yeah, in series. Oh, the charge stored in each capacitor, the potential difference across each capacitor. Okay, the working on the B here, the working done in B here is actually, you need to correct the question. The total charge stored, okay, the total charge stored in this circuit, the total charge stored. So the total, actually the B is the answer given for Q total, the total charge stored. The total charge stored is C total times V total. So C total here is 0.4 times 10 to the power of -6. And V total, the total voltage is how much? 200. So you get total charge stored in both capacitor together is 80 microcoulomb. Okay, it's 80 microcoulomb. Okay. So then, what is the potential difference across each capacitor? Okay, what is the potential difference across each capacitor? That means asking for V1 and V2. So V1 is Q over C1, right? The charge on the one of the capacitor divided by the capacitance. But charge for both same, right? Because in series, charge we know is 80 microcoulomb. Each capacitor store 80 microcoulomb of charge, right? 80 microcoulomb, 80 microcoulomb. Total also 80, right? So V1 should be Q over C1. So 80 times 10 to the power -6 divided by the capacitance of the first capacitor. Okay. Okay. So let me go one question in the whiteboard. Okay, we do together. Okay. Okay, now the whiteboard, let me give you one circuit. Okay. The circuit is like this. Okay. I have a battery. Let's say I give 20 volt. Okay. I have three capacitor, one. I have another two in parallel. Okay. And connected like this. Okay. This is 10 microfarad. Okay. This is, let's say, 20 microfarad. The bottom one is 40 microfarad. Okay. This is the circuit. Okay. Now, this is the first one, 1. This is 2. The bottom is 3. Okay. Okay. So this is the complex one, series and parallel together. Okay. So now I want you to find for me V1, V2, V3, Q1, Q2, Q3 for these capacitors at any sequence you feel should be any sequence. Okay, maybe you can find that you think maybe Q2 is can be found first or depend. So any sequence. Okay. So again, come on. 3 minutes for you. Can you find the answer? What is the voltage across V1? What is the voltage across V2? What is the voltage across V3? And what is the charge stored in each capacitor for this circuit? Come on, I give you 3 minutes. Okay. My advice is, before you find this, find for C total and Q total. Find this first, although they never ask for it. Quite helpful. Okay. Find these two first. Then you can work out one by one. The V1, V2, V3, Q1, Q2, Q3 separately. Okay, so whatever circuit, find C total and Q total first. Okay, first let's we go for C total. Okay, come on. How much you got C total for this circuit? How many microfarad? Can you give me 3 significant figure? How many microfarad do you get? C total for this circuit. You can WhatsApp me or you can tell me here or WhatsApp me. So 20, 40 and 10. Okay, 2 minutes for you, come on. Okay, so how do you do? So 40 and 20 you merge first, right? Okay, this is in parallel. Okay, this is in parallel. So 40, 20, the total capacitance is add up, right? So this is 60, right? This capacitance is 60. So we can imagine like this is 10 microfarad. The two capacitance here add up, it become, it's like 60. This is 60 microfarad, right? Okay, now this 10, 60, you merge. What is the total capacitance of these two capacitors in series? So it should be 1 over 10 plus 1 over 60 reciprocal, right? The total capacitance. Okay. Anybody? What's your answer you got? Shakil here? Shakil?
Yeah, so the total is 8.57.
8.57, eh?
So the SI unit for farad and microfarad, is it?
The SI unit for capacitance is farad.
Oh.
Okay, but normally all the capacitance they're going to give in terms of microfarad. Okay, you can leave it here microfarad if you want. Okay. Okay, so that's your C total. So now next Q total. Okay, so what is the total charge stored in this circuit? So what formula? Q equals what is capacitance? What capacitance is Q over V. So Q total is what? C total V total. C total V total is Q total. What? So C total is 8.57 microfarad. We leave it as microfarad. The voltage is total voltage is how much? 20. So the total charge stored in this circuit is how much? 20 times 8.57. So you got, you get 171. I go for 3 significant figure. 171 microcoulomb, right? Should be microcoulomb. This is the total charge stored. Okay. Okay, now let's we go to the what we need to look for. Q1, Q2, Q3, V1, V2, V3. Okay, which can find first? Anybody? Which quantity we can find first? Can we find V1, V2, V3, Q1, Q2, Q3? Which one do you think easiest to find first? Anybody? You know total charge is 171 microcoulomb.
Q1 also.
Very good. Q1. You can find Q1 first. Okay. The sequence you should able to find Q1 first, right? Okay. I told you like the charge you imagine like current. It's like a current. You know, the total current is the same as the current flow in the main circuit here, right? Okay. The charge also you imagine like that, analog to that. So the total charge in the circuit, you imagine like a current, the total charge is the same as the charge in the main junction, the main branch. So the Q1 is located at the main branch alone. So the total charge is actually same as the Q1 is same as the Q total. Okay. So Q1 is actually same as the Q total. So Q1 is how much? Is 171 microcoulomb. That's your first answer. Q1. Okay. So that's your Q1. Okay, after Q1, what you can find? We're done with Q1. After Q1, what we can work out? Anybody?
V1 as well.
V1, very good. We can go for V1, right? So what's your V1? V1 is Q1 over C1. Yes, good. So Q1 over C1. You know the Q1. So 171 microcoulomb over the C1 is what? C1 is 10 microfarad. 10 microfarad. So it's how much? 17.1 volt. Right? Yeah, 17.1 volt. So after you find Q1, you find the set. All the information about the capacitance you can find. Capacitor you can find. So after Q1, we be able to find V1, 17.1 volt. Okay, so we got V1, We got Q1. Okay. So next, what we can find? It's like a circuit again, right? Like analog to resistance too, like Kirchhoff, you know, the Kirchhoff first law also applied. The total EMF is equals to the total potential drop across the capacitor. It works for resistor, but we can analog to that. So you find one closed loop, the voltage across all the capacitors in that loop is same as 20 volt. So next, what we can find? The V1 plus the V1 plus the V1 plus the V2 should be equals to V total, right? Or we can say V1 plus V3 also V total, correct? Yeah, because it's a loop, right? In one loop. So next you can find is what? You can work out V2 and V3, you know. So what's the V2? V2 is from this equation above, V total minus V1. So V total is 20 volt minus V1, just now we got 17.1. So it's found to be how much? 2.9 volt. So V2 is 2.9 volt. Right? The V1 plus V2. The V1, V2 is in a closed loop with the battery, right? So the two voltage V1, V2 add up should be 20 volt. Then we can find V3 also if you want. Okay, V3 also we can find. V3 is V total minus V1, right? Or in other words, because V2 and V3 is parallel, no need to do working, or you can give statement. V2 is actually same as V3 because it's parallel. So no need to calculate. It's also 2.9 volt. Okay, so V2, V3 is 2.9 volt because parallel. Okay. Okay, so we got the voltages. Okay, now we can work out the Q2 and Q3. Okay, so what is Q2? Q2 is C2 V2, right? C2 V2 is your Q2. So capacitance 2 is 2 microfarad, so 20 microfarad, and the voltage is voltage of V2 is how much? V2 is 2.9 volt. So you get the charge on the Q2, the Q2. So how much you get? 20 times 2.9. So you got 58, right? 58, 58 microcoulomb. Okay. My advice, you know, at the beginning, the capacitance is microfarad, right? You don't change. Your charges all will get in microcoulombs. I think you better don't convert. And Q3, C3, V3. Okay. So C3 is what? C3 is 40 microfarad and voltage of the third capacitance is 2.9 again. So you get the charge torque. Okay, 40 times 2.9. You get the answer. So much got 116 microcoulomb. Okay, so this is how you analyze the circuit. Okay. So series parallel capacitor, they will ask what is the total capacitance. They will ask what is the voltage in each capacitor. This is how it's going to look like. Same like resistance in the circuit. Series parallel. Now it's going to be capacitor. Okay. So remember the 6 formulas. Okay, for the capacitor. Okay, 3 in series, 3 in parallel. Any questions so far?
So can you explain again why the capacitance is constant in series?
Why the capacitance is constant in series? What's the question? Capacitance is constant in series.
Can you explain again why?
Capacitance is always constant, right? What do you mean capacitance constant? Capacitance value is always constant, right? I couldn't get your question actually. If you have 3 capacitance in series, What's your question again?
Oh, sorry, I mean charge, the charge.
Oh, charge. Yeah. Why charge is constant in series? Yeah, that's a good question. Let's say you have one capacitor stores 5 coulomb of charge. Okay. You have another capacitor, let's say, also store 5 coulomb of charge and store 5 coulomb of charge. All are completely charged capacitor. All each got 5 coulomb, 5 coulomb, 5 coulomb. Okay. And these 3 capacitor, let's say you connected to a light bulb. Okay, you connected to a light bulb. Tell me, how much of charge do you think will passes the light bulb? How much of charge will passes this light bulb to light up the light bulb? How much of charge? Only 5 coulomb, right? See, this is positive, this is negative, this is positive, this is negative, this is positive, and this is negative. Okay. When positive 5 coulomb of charge, let's say, actually the negative charge is the one flow. Let's say here, the negative 5 coulomb of charge, let's say got electron, negative 5 coulomb of charge. When this electron move and passes the light bulb here, let's say the negative 5 coulomb, the charge passes is 5 coulomb here, passes the light bulb, and this negative 5 coulomb reaches this plate, the plate on the left side. What happened to this plate? Become neutral, because it's already a positive 5 coulomb. A negative 5 coulomb is just flowing and reach this plate, become neutral. Okay, so in between here, right, in between these two plates, in between here, the negative charge in this plate will flow to the other side to neutralize it. Okay, so negative 5 coulomb will go to the second plate of this capacitor, neutralize it. So the negative go to the positive plate to neutralize it. So all going to neutralize it. Okay, when this negative 5 coulomb of charge pass by the light bulb. So how many total charge move across the light bulb? Only 5 coulomb. When the 5 coulomb passes the light bulb, all the capacitor will be neutralized. So the total charge of this circuit is only 5 coulomb. Okay, the charge stored in one of the plate. Okay, so that's why the total charge stored in a series is same as the Q1 equals to Q2 equals to Q3. Okay, Angus?
Okay, answer. Then how about parallel?
Parallel is a different story. Parallel, let's say this is 5 coulomb, you have another one, let's say 5 coulomb, you have another one, 5 coulomb. Okay, so they store 5 coulomb of charge. Okay, when the light bulb, when this first capacitor, okay, first capacitor release the charge, let's say this is negative now, this is positive. When the first capacitor release negative 5 coulomb of charge, negative 5 coulomb of charge, the negative 5 coulomb will flow here to neutralize this. Okay, but the other two still have its charge or neutralize. So this can release another negative 5 coulomb and neutralize the second one. And this negative 5 coulomb also can flow here to do the neutralization. Okay, so to neutralize the charge, neutralize the 3 capacitor, negative 5, negative 5, negative 5. Negative 15 coulomb of charge must pass by the light bulb. 15 coulomb must pass by the light bulb to neutralize the capacitor. So the total charge going to pass by in parallel for this light bulb is 15 coulomb. Okay, that's why the total charge stored in parallel is Q1 plus Q2 plus Q3. Okay, so you want to store more charge, better fix the capacitor in parallel. Okay, in series, no, it's just same as the charge stored in one of the capacitor. Okay, Angus got the idea?
Right, answer.
Okay, class. Okay, so series parallel. Okay, we go to the slide. Okay, now this is your homework again. Actually, this is the question. 4 capacitors C1, C2, C3, C4 is connected with a 12-volt battery here. The 4 capacitors have the following values. The The C1, C2 is found to be at 90 picofarad P, pico, 10 to the power of negative 12. C3 and C4 has 45 and 120 picofarad. Okay, now question is, what is the potential difference across each capacitor? How much charge is on each capacitor? That means one the question asking, the one I asked just now lah. From V1 to V4, how much? Q1 to Q4 is how much? Okay. So you need to find V1, V2, V3, V4, Q1, Q2, Q3, Q4 by using what formula? Capacitance is Q over V and the series parallel equations lah, the 6. Okay. So actually the working is the next slide. Okay. Before you view that, okay, just 1 minute. I stop in 1 minute. Okay, tell me your idea. What you're going to find first? Which can be found first in this group? Of course, first you need to find the C total and Q total first lah. Make sure you find the C total and Q total first. After you find C total and Q total, which quantity you can find here first? Anybody? Q1, V1, Q2, V2. Which one? Tell me the order. Anybody? Which one you can find first? Q1, C1 is here, C2 is here, C3 is here, C4 is here. Which you can find first? Q1 to Q4, V1 to V4. Which quantity you can find first? Anybody? Jajuan, yeah?
Maybe Q4 first.
Very good. Q4, right? You can get the Q4 first. You can get the Q4. The charge in the main branch first. You know Q total? Q total is the same as the current Q4, right? So you can find the Q4 first. Once you know Q4, you can find V4 already, right? You know, so Q4, then you can find V4. Okay, right? So after you find Q4 and V4, what you can find first? Anybody? Look at the circuit. Now you know Q4, V4. What you can find after that? You can use Kirchhoff law, right? The loop case, loop. You take this loop, the smaller loop here. The 12 volt is same as the voltage used by what? 4 and 1, right? 4 and 1 is like one loop, right? With 12 volt. So V4, you know, you already found just now. So what else you can find out of that? You can find V1, right? Yeah, correct. So V4 plus V1 is 12, right? So you can find V1. Okay. Okay, good. Q4 first, V4 you can find, then we can find V1. V4 plus V1 is 12. After V1, what you can find? Of course, you know V1 means you can find Q1 lah, right? The fourth one you can find is Q1, right? C equals to Q over V. C1, V1, you can find Q1, right? You can find Q1. Okay. So now, what you can find later? After Q1, you can find what? After Q1, V1, you know Q1, V1. Can you find Q3? Can you find Q3? How do you find Q3 if you know Q1? Q1 plus Q3 is what? Q1 plus Q3 is what? Like current, right? The current splits into two branches, right? So charge also like split lah. You can analog to that. So Q1 plus Q3 is what? Q1 plus Q3 is actually Q total, the total charge stored, right? Total charge, you know what you already found. So after Q1, you can find Q3. You can find Q3. Okay. Okay. So slowly you explore like this one by one. You can able to find the total, all the 4 voltage and all the 4 charges just by using C equals to Q over V. Okay. Okay. This is your homework. Of course, we're going to explore this further on Monday. Okay. So try to look at the solution, but before you look at the solution, this is the answer you should get, and these are the answers you should get. Okay, get the working for me. Okay, so on Monday I want the working for this one. Okay, any questions? So what you learned today? You learned capacitor in series and parallel. 6 formulas. Okay. Then after that we did some questions to try to get the idea of how to get the voltage and charge of each capacitor. So I think time's up. So I stop here. Any questions? Okay, so do the question first. So maybe on Monday, maybe you have some questions you can ask me. Okay, thanks.